Fade in, a dusty basement office in early 20th century Harvard, where dozens of women in starched collars pore over fragile photographic plates, scrutinizing pinpricks of light. This was the workplace of the so-called Harvard computers, a group of brilliant women, but none shone brighter nor stayed more hidden than Henrietta Swan Leavitt. Henrietta arrived here, to the Harvard College Observatory, in 1893. Her official title? Human computer. Her pay? Barely livable. Yet Henrietta brought with her a secret, an unyielding sense of wonder for the universe, and an attention to detail that bordered on obsession. She didn't care for parties or limelight. What captured her heart was the night sky, and its endless mysteries. But in this era, women were rarely seen as scientific equals. They were expected to catalog, to count, to compile, but never to discover. Henrietta was even more marginalized. Her hearing began to fade as she matured, leaving her isolated in a world already determined to keep her silent. She listened to the stars instead. Her task was monotonous, painstaking, to measure the brightness of thousands of stars captured on glass plates sent from distant observatories. But as Henrietta compared variable stars, those whose brightness changed over time in the Magellanic Clouds, she noticed a pattern that no one else had. She began, quietly, to record her findings. Over sweltering summers and freezing winters, day after day, Leavitt's world shrank reliably to that desktop, her eyesight, failing hearing, and sharp pencil her only companions. Long after the others had abandoned the problem as tedious, she worked on and on. Each speck of light was a clue in a puzzle she felt compelled to solve. Then, one day, the pattern emerged. For a special type of variable star, the Cepheids, their intrinsic brightness was tied, in a perfect mathematical relationship, to the period of their flicker. The brighter the Cepheid, the slower it pulsed. The implication? If you could measure the star's flicker, you could know its true brightness and, therefore, its distance across thousands, even millions, of light years. This was the cosmic yardstick, the ruler for the universe. In 1912, Leavitt published her discovery quietly, without fanfare. She still earned only 30 cents an hour. But she had, unknowingly, unlocked the method that would enable Edwin Hubble to measure the expansion of the universe, to prove galaxies exist, to show us the true scale of the cosmos. Her work set off a revolution. Astronomers now had the key to measure distances far beyond the Milky Way. The universe, once a dark and immeasurable gulf, suddenly became vast, real, and shimmering with possibility. Henrietta never saw the magnitude of her impact. She was nominated for a Nobel Prize in Physics after her death. She died, largely unknown, in 1921, at just 53. Legacy was never her ambition. Yet, thanks to Henrietta Leavitt, humanity gained a sense of scale, of humility, and awe. Fade out, the image of her handwritten charts, leaving behind a beacon through the darkness, a code by which astronomers still navigate. The quiet, blind astronomer had